Hello, hi everyone. Welcome to the Student the Brand. So it's okay. So don't worry about it. Okay, already you circled right. So did you inform to the insulator ma? So regarding that one. So regarding YMR sheet, if you informed to them, so they will take care. Don't worry about it. Okay. So no need to worry about that. Okay. So whatever it happens, immediately inform to the insulator. Okay. So if anything happens during exam, so like this type of things, like OMR sheet mistakes or something it happens. So immediately inform to the invigilator who are there in the exam hall. Okay. So inform to them. Then they will take immediate what can be done. So they will take suggestions from higher authorities. They will according to that they will follow. Okay. So even I did the invigilation. So for grade 10 CBSE board exams. Okay. So it's okay, fine, no problem. It happens. But so take care next time onwards. Take care about things. So don't worry about these type of things. Okay, don't take too much. So not required. Just leave that. Okay. So if you already informed, no problem. If you already informed to the insulator, so according to that they will consider. Okay. So don't worry about it. Already this exam is done. So it was right. So it is already it is done. So now we are coming to the science exam, right? So focus on science exam. So now you no need to worry about it. So 23rd, 24th, and next one 25th. So 25th only exam. So now you are worrying about it. So it's not good sign. So be strong. That's enough. Nothing else. Everything will be go in a good manner. Okay. So come to the point. Next one we'll discuss about light reflection and diffraction. Light reflection and refraction. Light reflection. Light reflection and refraction. Light reflection and refraction. Okay. So here you can consider when the light is incidenting on the surface, when the light ray incident on the surface, the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So I'm taking this the plane mirror. So this is the plane mirror. So this is the plane mirror. So this is the incident ray. Incident ray. Incident ray. Okay, and coming to the reflected ray. This is the reflected ray. Reflected ray. Reflected ray. And coming to the normal line. So this is the normal line. The line which is perpendicular to the plane surface. That is normal line. Okay, so the angle between incident and normal line is called angle of incidence. So I am taking this one is the undeviated line. Undeviated line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. This is the angle of deviation, you can say. So angle of deviation. Angle of deviation. Understood or not? So linear angle is 180 degrees. We know that linear angle is 180 degrees. So I am taking linear angle is 180 degrees. So coming to that, we know from laws of reflection, laws of reflection, laws of reflection. Point number one, first one, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Point number one. Coming to the point number two, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Okay. So this angle of deviation formula is very, very important. Angle of deviation formula. Okay. So now based on that one, they will ask questions also. Based on that one, they will ask questions. And one more thing, So when light ray passes along the normal line, when the light ray is passing along the normal line, it reflects back into the same path. If it reflects back into the same path, it moves in the same direction. That time, angle of incidence is equal to 0, angle of reflection is 0. So here if you are taking angle of incidence is 0, angle of reflection is 0, and coming to the angle of deviation is 180 degrees. So very very important. So this type of question they will ask in the exam. This type of question they will ask in the exam. So make sure that you are learning this point. And coming to the next one, angle of deviation. So we have to find out the angle of deviation formula. So let's start identifying the angle of deviation. Point number one. So here you can see angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Understood or not? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From loss of reflection we can write angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. So now you can observe here. So angle of incidence is equal to angle of reflection. Understood or not? Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. So that angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. So how can you take? So from loss of reflection from this, angle of incidence is equal to angle of reflection, right? Angle of incidence is equal to angle of reflection. So that's why we are taking like this. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 angle of incidence. So instead of angle of reflection, I am writing angle of incidence. So angle of deviation equal to 180. Angle of deviation equal to 180 minus 2 angle of incidence. So angle of deviation equal to 180 minus 2 angle of reflection. And here, so one more question. Angle of deviation, sometimes angle of incidence they will give. Angle of incidence is equal to 30 degrees. So find out angle of deviation. So here, so we can take this formula. So we can take any formula, but angle of 180 minus 2 into 30 degrees, then you'll get 180 minus 60, then you'll get 120 degrees. Understood? Angle of deviation equal to 120 degrees. So even if they give 60 degrees, 70 degrees also, okay, so you'll get the same. Understood? If you same formula we can use. If you are taking angle of the incidence is 60 degrees, so I'm writing angle of incidence is 60 degrees. So what about angle of deviation? What is the angle of deviation formula? So 2 into 60, 120, 180 minus 120, 60 degrees. Is it correct? 60 degrees. Okay, so 180 minus 120, 60 degrees. So like that we can solve it. Understood or not? I hope it is very clear. So this type of questions like this they will ask. And already mentioned angle of incidence is 0, angle of reflection is 0, angle of deviation is 180 degrees when light ray is passing along the normal line. And one more point, so the angle between incident ray and the plane surface is called, this surface is called glancing angle of incidence. Sometimes they will ask this also. So angle of incidence they will give, okay, angle of incidence is 30 degrees. So what about a glancing angle of incidence? So like that, angle of reflection they will give. So angle of reflection is 60 degrees. Find out glancing angle of incidence. Like that also they will ask. So perpendicular angle 90 degrees, right? Accordingly we can take. Accordingly we can consider. Understood or not? So this is the glancing angle of reflection. Angle between reflected and plane surface. Reflected and plane surface is called glancing angle of reflection. Angle between incident ray and plane surface is called glancing angle of incidence. Glancing angle of incidence. Understood or not? So very very important. Make sure that all the points you are learning and keeping in mind. And coming to loss of reflection. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Okay. Okay, done. Come to the point. Next one. So we'll discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular or irregular. So here directly they won't ask regarding the regular reflection and irregular reflection. Directly they won't ask. They will ask about okay. So plane mirror reflect light rays and wall also reflect light rays. So what is the difference in the reflection? So explain with your words, like that they will ask. Understood or not? So plane mirror also reflect light rays and wall also reflect light rays. So what is the difference in their reflection? So plane mirror reflect a regular reflection. Okay, regular reflection takes place on plane mirror, whereas wall, so irregular reflection takes place. So what is the meaning of regular reflection and irregular reflection? So now observe here, regular reflection, regular reflection, regular reflection. Here condition is very important. Condition is very important. So I am taking the plane mirror like this. Plane mirror, incident light rays are parallel. These are the incident light rays. These are the incident light rays. Okay, these are the incident light rays. Incident light rays are parallel. Then reflector light rays are also parallel to each other. Incident light rays are parallel. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Incident parallel beam. Incident parallel beam. Okay. Incident parallel beam. And coming to here, reflected parallel beam. Reflected parallel beam. Understood? Reflected parallel beam. Is it clear? Okay, so regular reflection takes place on smooth surface. Example, plane mirror. So example, we can take plane mirror. So whereas irregular reflection takes place on rough surface. Okay, so here you can say, so I'm taking the irregular reflection. So irregular surface. Irregular surface. This is irregular surface. Okay, so one side is reflecting surface, another side is coated one. Coming to irregular reflection. Irregular reflection. Irregular reflection. Here you can observe irregular reflection. Incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but so reflector light rays are moving in different directions. Reflector light rays are moving in different directions. Understood or not? Like this. So these light rays, reflector light rays are moving in different directions. So regular reflection and irregular reflection. Regular reflection takes place on plane mirror, whereas irregular reflection takes place on rough surface. Best example, wall I can say. Okay, wall. Next. So we'll discuss about object and image. Object and image. Object and image. So very important. Diagram is very important. Examples very important. So exam point of view. So examples they will ask where regular reflection takes place, where irregular reflection takes place. So give an example. At least 2 examples they will ask. Okay. So 2 examples they will ask. Regular reflection example, plane surface and still water surface of lake. Okay. So on still water surface of lake, regular reflection takes place. And coming to irregular reflection, so you can take wall and book also. So book also you can take. Okay. So irregular reflection takes place. On cinema screen also irregular reflection takes place. Understood or not? Okay. So next, object and image. So here is very important, object and image. Object and image. So here you can observe object and image. So light rays are coming from the source. Light rays are coming from the source. So here definitions are very important. So this is a real image. Real image. What is the meaning of real image? The point of intersection of reflector light rays. Reflector light rays are meeting directly. Reflector light rays are meeting So this is the I1, R1, I2, R2. Okay, so we are extending this light rays and here also extended. So this is the virtual object. Virtual object. So why virtual object? Extended incident light rays are meeting. Extended incident light rays are meeting. Here you can observe directly reflector light rays are meeting. Directly reflector light rays are meeting. So that's why that is a real image. Directly reflector light rays are meeting. That is a real image. So coming to the virtual object, the point of intersection of extended incident light rays. So we are extending the incident light rays. Those extended incident light rays are meeting at one point. There virtual object is forming. Okay. And coming to the one more. So here I am taking a plane mirror. So this is the plane mirror. So from this point I am taking this the point. Okay. This is the real object. From this point the light rays are coming. Okay. After reflection those are moving away from it. Those are moving away from it. Okay. You can observe this one. If you are extending the reflector light rays, extended reflector light rays are meeting at one point, so their image is forming. That is a virtual image. Virtual image. The point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of incident rays. Incident rays are coming from this point, so that's why this is a real object. We are extending this reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Virtual image. Here you can observe. So real image, directly reflector light rays are meeting. Virtual object, extended incident light rays are meeting. Here you can observe. We are extending the reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. That is a virtual image. So now you can observe. So object is real, image is virtual. Object is real, object image. Object is real, image is virtual. Object is virtual, image is real. Understood? Object is real. This is the real object. What about image? Virtual. Object is virtual. Where is object virtual? This is the virtual object. Where image is real? This is the real image. Okay. So if the object is real, image is virtual. If the object is virtual, image is real. Vice versa. Vice versa. Understood or not? I hope it is very clear. I hope it is very clear. Next one we will discuss about nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So the definitions are very important. The point of intersection of reflector lights. So the point of intersection of reflector light rays is known as real image. So directly reflector light rays are meeting at one point. That's called it is real image. The point of intersection of extended reflector light rays is called virtual image. Okay, extended reflector light rays meet. That is a virtual image. Directly reflector light rays are meeting at one point. That is a real image. Okay, so very important. Okay, I hope it is very clear. Now you can observe. So nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So now we will see. So this is the object. This is the object. Okay, so object is real, image is what? In plane mirror, you can observe object is real, image is virtual. Object is real, image is virtual. Okay, so we are extending the incident light rays. Extended incident light rays are meeting. So here you can observe this point I am taking one light ray, another light ray. So actually in the previous example I mentioned one thing. When the light ray is incidenting on the surface, it reflects back, it bounces back and it takes its original path. Okay, so like that only, if the light ray is passing along the normal line, so here you can observe one more point I am taking here and this will be reflected back, and here one more point I am considering like this, so here it will be reflected back like this. Okay, so if you are extending these light rays, If you are extending these light rays are meeting here. These light rays are meeting here. So this is the A dash and B dash. So this is AD. So AB. A dash and B dash is the virtual image. So AB. Understood or not? I hope it is very clear. Okay. So now object is real, image is virtual. Point number 1, object is real, image is virtual. Okay, so object is real, object and image. Object is real, image is virtual. Object is virtual, image is real. Okay, so point number 2, object distance is equal to image distance. Object distance is equal to image distance. And coming to the next one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Coming to the fourth one, that is, so we can see here, so magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Coming to the fifth one, it also shows lateral inversion. Lateral inversion. What is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Okay. If object is real, image is virtual. If object is virtual, image is real. And object distance is equal to image distance. And height of the object is equal to height of the image. And the magnification of the mirror is +1. Magnification of the plane mirror is +1. And it also shows lateral inversion. Understood or not? Sir, what do you mean by lateral inversion? Lateral inversion is nothing but if you stand in front of the mirror and raise your right hand, it appears in the left side. If you stand in front of the mirror, so if you lift your left hand, it appears in the right side of the image. Okay, if you lift your left hand, it appears in the left side. If you lift your left hand, it appears in the right side. Right hand, left side. Left hand, right side. Okay. So this mirror image is called lateral inversion. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. I hope it is very clear. So they will ask one question. Can you give one example for lateral inversion? And what is the cause of lateral inversion? The cause of lateral inversion is, so object and image is facing each other. So both are facing each other. So that's why both are facing each other. So lateral inversion is happening. And one more thing, coming to the next one. So related to mirrors, so nature of the image formed by the plane mirror, related to that one they will ask. And define laws of reflection, write about laws of reflection, define reflection of light. Define reflection of light, one question. Write about the laws of reflection, second question. And third question is, when light ray passes along the normal line, so what about angle of incident or angle of reflection, angle of deviation? That is third question. And coming to the fourth question, so it's related to object and image. So like MCQ's point of view, real object, virtual image, virtual object, real image, related to that question they will ask. And coming to the next one is, okay, so plane mirror completion. Next one we will discuss about spherical mirrors. Let's discuss about spherical mirrors. Spherical mirror. So what do you mean by spherical mirror? The mirror which is in the form of curved shape. So curved shape, like this. Okay, so I'm taking the concave mirror. I'm considering the concave mirror like this. This is the concave mirror. concave mirror. Okay, the center of the imaginary sphere, the center of the imaginary sphere in which mirror is a part is called center of curvature. First one is center of curvature. First one is center of curvature, and second one is the midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. So here you are taking the line joining of center of curvature and pole is called principal axis. Principal axis. And coming to the fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. This is the radius of curvature. And coming to the fifth one, so after reflection, all light rays will meet at one point on the principal axis. So that is, so here you can observe these are the light rays. After reflection, those light rays are meeting at one point. Here you can observe. So this is the focus, capital F. And coming to the next one, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Focal length. And coming to the seventh one. Okay. So width of the reflecting surface. This reflecting surface is called. So width of the reflecting surface is called aperture. Width of the reflecting surface is called aperture. Aperture. So center of the imaginary sphere in which mirror is a part. So center of curvature. Midpoint of the mirror is called pole. The distance between center of curvature to pole is called radius of curvature. The line joining of center curvature and pole is called principal axis line joining. And after reflection, all light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called focal length. So denote with a small f. And the width of the reflecting surface. The width of the reflecting surface is called aperture. I hope it is very clear. So these are the terms related to spherical mirror. Terms related to spherical mirror. So now we will discuss about so ray rules are spherical mirror. 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 Spherical mirror. So now we will discuss about ray rules of spherical mirror. So here two types are there. One is concave mirror. Another one is convex mirror. Concave mirror and convex mirror. Coming to the concave mirror. Concave mirror. Concave mirror is in converging nature, whereas convex mirror is in diverging nature. Concave mirror is in converging nature, convex mirror is in diverging nature. First one I am taking this concave mirror. So maximum generally they will ask about what are the ray rules used to draw the image formation when the object is placed between center of curvature and pole. So they will ask about ray rules. Okay, describe the ray rules which you are selected. Okay, so what type of ray rules you selected? About that one they will ask. Pole, focus, center of curvature. So first one, light ray is coming from infinity. After reflection it passes through focus. And coming to the second one, light ray is passing pole, focus, center of curvature. Light ray is passing through focus. After reflection it moves towards infinity. That is the second one. Coming to third one you can observe here. This is the pole, focus, center of curvature. Light ray is passing through center of curvature, so it moves in the same direction. Coming to the fourth one. So pole, focus, center of curvature. So light ray is incidenting at the pole, it reflect back. Okay, so light ray is incident the pole, it reflect back. So that's enough. And coming to the next one, convex mirror, convex mirror, concave mirror and convex mirror. Convex mirror also same. First one is, so I am taking the pole. So this is the pole, focus, center of curvature. Light ray is coming from infinity, after reflection passes through focus. Okay, so it passes through focus. Second one, pole, focus, center of curvature. Light ray is passing through focus. After reflection, it moves towards infinity. Coming to third one, this is the pole, focus, center of curvature. Light ray is passing through center of curvature, so it moves in the same direction. Okay, so it retraces its original path. Okay, coming to the fourth one. So pole, focus, center of curvature. Light ray is incidenting at the pole, it reflects back. Understood or not? I hope it is very clear. Just check once. Next one we'll discuss about image formations. So image formations. So image formations by concave mirror and convex mirror. Okay, so let's start. So point number one. So I'm taking here. So pole, focus, center of curvature. Object is placed at infinity. One light ray I am taking like this. Another light ray I am taking like this. After reflection, the light rays will meet here. Okay, so object is at infinity, image is forming at focus. So nature of the image is real and inverted. Size of the image is highly diminished. Okay, so because point size image is forming, point size image is forming at focus. Okay, next one will do. So next one, second one. So I'm taking the concave mirror.